one jelly bean left, and you guys are like, no, I want it, you can just cut it in half.
Well, don't like do that, Will.
That's what rock paper scissors is for.
Be overthinking it. But that's good. That's good. Ask those questions. Animals. Hopefully you wouldn't chop an animal in half. That would be sad.
What else? You're
How about rocks?
You can break them in half, but then there are 2 more rocks.
Rocks or half of it.
Rocks.
Okay.
Once you cut it in half,
Hard to cut a person.
3, 2, 1. Alright, so we're basically just talking about what types of things make sense to count with the natural numbers, the whole numbers, the counting numbers they're sometimes called, and what things require a different number set to keep track of. So, this table back here, let's see, Jackson, will you report out what you guys talked about?
For number 1, we said people.
Oh, why did you choose people?
Because we can only count up by one person at a time. We can't count up by half a person.
And what would you put in the second column? Money. And why two? Why money?
Because there is like a half a dollar or
Okay, there are amounts in between those whole numbers. Okay, so our goal today, as you noticed when you came in, is to compare and contrast sequences to continuous functions. So our whole last module, we worked with sequences. And what kinds of sequences did we talk about? One kind, Marco? What? One kind of a sequence that we talked about last module. Okay, you did both. Arithmetic and geometric. Okay. We talked about 2 types of sequences, and now we're going to take what we know about those 2 types of sequences and compare them to other types of situations, continuous functions. And remember that we're starting a new module, and at the beginning, what are the activities like? What kinds of things are we asked to do? You're learning it, it's open-ended, you're kind of exploring. You're not expected to necessarily have the right answer. You're just seeing what you can pull out of the activity. So, I am going to erase this. I'll leave our list up though. A lot of the work that we do today is going to be really familiar. You're going to be asked to create equations, tables, graphs. All of those representations we used for sequences. So it's great practice for those of you who still need practice with the Module 3 stuff. And then we're going to take it a step further. So I'm going to actually give you the activity today. I usually put it on the overhead. But I want you to do the work in your notebook. I was just worried that there's a lot of text and you wouldn't be able to see it well. But I still want all of your work to go in your notes or your notebook. Some of the representations we can use for a situation that we talked about last month, okay? You can use an explicit formula. Aiden?
we can use a cursive.
A cursive formula. What other ways are there to represent the situation, Giselle?
A table.
A table. Nora?
A graph.
A graph. Okay, does that about cover it? Oh, Sarah, do you have a sequence? It'll be appropriate to write a sequence. Okay. So here are a bunch of representations. For those 4 scenarios at the top, I want you to work on creating as many of those representations as you are able. Okay, I'm going to come around and look at your work, and I want you to work for the first bit on your own. I want you to practice some of the skills from last module, which you should have down pretty well, and just see how you're doing on your own. And then you can have time to work with table partners.
Okay.
Okay, this is what I'm going to ask you to do. I'm going to ask you to get up. This may be a little chaotic for a second. I want you to get up with your stuff. I want you to find a crosstown partner, sit down, and compare your work. And if you are missing a representation, maybe your partner will have one that you need. We can complete that in our group discussion now. I want you to stay in your crosstown location for now. Let's look at numbers 1 and 2 first. And I'm just going to ask you what you noticed about those two situations. Okay? We'll make a little, we're looking at numbers 1 and 2 right now. And I want to know if you saw any similarities, differences between those two situations. Okay, so take a minute to look at what you've got. Similarities do you see and what differences in those two? Jaime, what's one thing you noticed about those first two?
First two?
Mm-hmm.
They were pretty similar, but the first one was counting money, and Phil was asking how much, and when would, how much gallons you would get in how much minutes.
Right.
So the first one was asking how much money she had.
Okay, so what was one thing you noticed that was the same or different between those two situations?
They're both geometric.
Geometric means what? Arithmetic is the word that you're looking for there. And what is the difference between geometric and arithmetic? Liam?
Well, arithmetic is adding or subtracting by constant numbers.
Okay.
And geometric is multiplying or dividing.
Okay. So Jaime noticed that both of those first two situations had a common difference. Okay, and okay, arithmetic is a word that we use there. All right, I'm going to ask will you sketch your graph for 1 and 2, just very quickly up here? Okay, taking a look at Will's graphs here, who can tell me something that looks the same about them?
Is that a straight or curve?
Straight.
Okay.
Wow. There are lots of them. Okay, actually put your hands down and just at your table, discuss what's the same and what's different.
Those are linear.
So that's not you have a straight line.
Lisa, I
No, that's what
linear.
Yeah, they have straight lines.
They said they both have straight.
Okay. 3,
They both start at
2, 1. All right, Dawson, your table, what's one thing you noticed about those two graphs?
Both of them are arithmetic.
Meaning what?
That both of them are straight.
There's another word we could use for that? Linear, arithmetic, straight. I'm going to write all those words up here. Another observation, let's see, from Toby, your table.
That's not a lot.
1 is not a line. Which one is not a line? Sorry, this is number 1. And this is number 2. And what do you mean by it's not a line?
It's not like just a snap line.
Okay, so you're seeing these individual dots that are not connected, whereas in number 2, the points are connected. Let's think about those two situations. So, thinking about the first situation with the number of pennies and the number of days and the number of pennies on each day, what would happen if I said, how many pennies do you have on day 1? 1.5.
Oh.
What would happen there? Can you guys just flip your calculators on these? Okay, so the question is, on day 1.5, how many pennies do you have? Kyle? And is that the same number that you have on day 1?
Yeah.
Because you don't get more pennies until when? After school on day 2. So in between here, in this whole area, you still have 8. There's not a change in the output until you get to after school on the next day, right? But if you, and what did you say, Jackson?
It's called the discrete.
And where did you find that word? In your notes, I can't believe it. From when?
Oh my god.
Does this homework?
Okay, so a long time ago, this came up in one of the homeworks. This is going to be an important word in this module, but that's a great way to describe what we're seeing here in this first pattern, is that it's discrete. There are individual points that make sense in the situation, and the spaces in between, there's no value there. There's not a different value there. There's nothing between these 2 points. You have 8, and then you have 11. Or I should say, yeah, 8, and then you have 11 at the end of the next day. Okay? What if I asked you how many gallons are in the pool at 1.5 minutes? Okay, so think about that, and at your table, quickly say how many gallons would be in the pool at 1.5 minutes.
1.5 minutes, there'll be 8.
We're going to finish our group discussion about numbers 3 and 4 tomorrow, on Monday. But your exit ticket is to explain the difference, or actually I'm going to word it this way. I want you to make a little chart like this. This is situation number 1 and situation number 2, and I want you to give a